Hey guys, it's Ben with Myers Woodshop, and this is the first look at the Elite Series from Onefinity. This is the Foreman. This is the 4x4, the biggest one they make, with the Masso controller. So take a look of it in all its glory. Now I have to mention, this is not a production unit. This is, I would like to say, a 95% production unit. There are still some things that aren't perfectly production that you will see different in the future. But this is as close as it gets, and I've been using this for some time. So let me take you in on a closer look at all of what this Elite Series has to offer. The very first thing you'll notice is this is the massive touchscreen controller. I want to make sure that you are clear on this. This screen, unlike the regular X35 and X50 machines, this is the controller. You can't use a different screen size. It's not a USB, HDMI screen. The guts are inside of this, so you have to use this screen to control this controller. The good news is it's massive. You can see my hand. It's small compared to my hand. This is 15 plus inches. I have had no problems with this screen. We have an emergency stop, we have a start, and we have a pause button down here as well. And then at the bottom we have one USB slot for our USB stick that is required to be able to use the machine. The machine has no onboard storage for your G-code. Everything is on the USB stick. So let me open this up so you can see what's inside. To open the screen, undo these 4 bolts here. I'm not even having to take them all the way out. And then the hinge opens up just like that. And here is the guts and the inside of the machine. This is the controller itself. That big black box you have with the X35 and X50 houses similar stuff in its box, but in this, the screen actually houses the controller. So it's a Masso G3, and this is the 5-axis, and it is enabled from the factory. You do not have to buy any more software or upgrades to get the 5-axis availability from this G3. So here is all the wiring that goes on and the controller. So that's a look at the inside, and if you see on this side, it is a laptop screen essentially that is in here. This is not user replaceable. This is from the factory. You're gonna have to use this screen. Just wanna make sure that you are fully aware of what you're getting with this Masso screen. It is integrated and there is no changing that screen. However, in my use case, you really don't want to. All right, of course you're gonna ask about the holder of the screen because the first screen was magnetic. This is not magnetic, this is metal. So on the back you see we have a plastic connector that has a hole down here. This is a solid piece of aluminum, this big black piece that goes into the solid ABS connector on the end of the foot, and then we have a screw down on the bottom to keep this in place. You're not going to bump this off unless you really bang into it, but it sits right on there like that, and then you are enabled to rotate the screen like so. You can push it in, you can push it over this way, you could pull it forward, you could rotate it this way, you can rotate it that way. Very simple, and it's not going to be pulled off or banged off or shaken off. It is very solid. Okay, here's a close-up look at the back of the connector, and here's where I said my machine is 95%. This back piece is not completely final. It'll look very similar. Mine's in white, yours will probably be in black. I just printed this in white because they changed it after they sent it to me. We have the Z, the X, the Y, the power, and then down here we have tool setter, XYZ probe, and laser. You'll notice I have a missing port. This is where the rotary will get plugged into. And then we have a big hole in the back. This is for extra accessories like a spindle or a pendant, or however you want to connect other things right there. So this may change in the final version. This is about 95% right. This is the one item that is different on my controller than the production. So that's what the back of the controller looks like in connections. For those of you with enclosures, what I don't know at this time is how long you're gonna be able to move the cords. This is how long I have to get away from it. Then hopefully we'll have some extension cables. So if you're gonna mount this thing anywhere else other than the end of the rail, ensure you buy the extension cables if they make them. I'm assuming they're going to. That is something I recommended to them in testing. So that is the controller and the plugs. That's what it looks like. If you notice down below, I have another black box, and that looks very similar to the black box controller for the X35 and X50. But let me show you what actually this does. So this is one of the other items that is not 100% complete on my pre-production version. This is the power. So the power supply is inside of this and the relays. So on the front, we have a power hookup for every single axis. So we have X, Y, Z, Y2, and then we have a rotary port, which I don't have at this time. And then in between here, we have a fuse for every single axis. And if a motor driver gets blown or something like that, it should blow this fuse before it blows the motor driver. And then they're very simple to change out. You push them in and twist, and there's a fuse inside, and you can just change that fuse out and push in and plug it in. The one thing that's different on mine is the power switch. There will be, I'm told that it's gonna be a push button, and right now I have just an external power switch that looks funky, but this will be different in pre-production. And then finally, we have a power cable right here that's labeled A. That's really just the power that turns on the Masso controller and screen. On the back side, we have a router cable plug to turn on the router if you use a router. This is not for a VFD or spindle. That VFD and spindle must be plugged into a wall outlet. But if you have the router, you can plug it in here. And you notice it's universal, so this will be used in 220 and 110. So there's no problem or issue with going to a different country. And then on the right side, that will auto turn on your vacuum. It is turned on with G code for the vacuum and the router. And then inside, you'll see we have the power plug for the main power that gives power to everything. And then we have 3 fuses. This fuse will be for router, this fuse will be for vacuum, and this fuse will be the main fuse for the power itself. So I'm gonna plug in the power, and this controller is ready to be turned on. All right, let me go over some of the other things about the Elite Foreman that are different. Right now I have a tool setter. This is a work in progress. This was something I made to wire up to test. This is not what the tool setter will look like. I don't have a final version. So your tool setter will be totally different than mine. This is not a production one. So that is the last bit of what I have here that is not production. So the only thing that's different in this video that you will get when it's production is tool setter will look totally different. The power supply will have a push button, and the back of the Masso controller where all the ports go, that will look slightly different. Those are the 3 things that are different. Everything else is production and will look just like what you get when it comes from the factory. So you'll notice I have big motors on my Z-axis, my X-axis has them, my Y-axis. I'll take you in and give you a closer look. But the difference is these are closed loop steppers. So a closed loop stepper is different on the Elite series than the regular X50 or X35 series. Those series have an open loop stepper. And the difference between an open and closed loop stepper is the open loop stepper, the controller tells the motor, hey, go 100 or 200 or some sort of distance and do something. And the motor says, okay, I'll send that signal out to the rail and go. It has no idea if it actually is working because no information is coming back to the controller to let it know, oh, I went this far or I missed a step or something like that. A closed loop stepper has a closed loop where it goes out and sends the signal and the motor knows what it did and tells the controller back what it did. So this will say, hey, I missed a step or I'm not going fast enough. The controller is smart enough now because it got a signal back to say, oh, I need to compensate for that. Let's fix that step or go faster or slow or something like that. So these are a step up in the open loop system. Closed loop is definitely a better system. And that's the big deal for these motors, why they look different and why there's this big thing on the side. Let's take a look at these motors up close. Here's what the motor looks like themselves, and they have a big heatsink on the back. That's why they're longer than what you're normally used to. The motor is here, heatsink is here, and on top is actually, and I took the screws out so you can see, on top is actually the motor driver. So it has a whole bunch of wires for signal, and then it has 2 for power, and then the alarm and power LEDs, and the driver that makes this thing work. So that's why these motors look different, and this is simply a cover to cover them up for protection, and that is what the Masso motor looks like. Next, we'll take a look at the drag chains. You'll notice this is the back of the X-axis rail, and the drag chain sits on this channel and comes all the way up to here with the wires. Now, of course, I have a laser wire just dangling here because I haven't permanently put it in here yet, but the drag chain will hold your Z cable and your router or spindle cable, and it goes along this custom-made piece that is aluminum across the back, and then we have another one on the Y. Let me give you a closer look at the Y. There is the Y cable. You'll notice there's a plastic piece in here that's ABS that holds on this metal aluminum channel that holds the drag cable all the way across to the front. So that is what the Y and X look like. I think they're both very, very similar. You can see we could fit our Z cable, our router cable, or a spindle cable. We could probably fit our laser cables in there. I don't think we could fit our water cables in there. I think we have 2 of those. If you have a water spindle, it's gonna be too big. So you're gonna wanna maybe zip tie them to the back of this and run along it. It does not have a port for water cables to go through here. It's really nice because our router cable ends here, and we'd have to add a extension cable going through the Y. But if we wanted to, we can simply disconnect these connections right there, and we can remove the X axis now without having to open up the drag chain in any way, which is a really nice feature if we have to do maintenance or something like that. So we have this new connection here, and that is for the new infrared homing. I'll take a look at those right now. Okay, so we have an infrared homing switch up here. This is the X axis. We have one on each Y rail, so there's one there, and we have one over there. And they are independent homing, so it will home this side, and it won't just stop here thinking only one side is homed. It'll home the other side as well. Now you can see the gantry block is a little different. It has these new connection points on this gantry block, and this is where the homing switch will actually go into this access point right here and break the laser beam, and it'll know it's homed. I'll show you that when we turn the controller on, but know that it is on the X and both Ys, and it is also on the Z. This is the heavy duty Z, it's right here. It will break right there when the Z comes up and breaks that point. So 4 axes have new optical homing switches. So you notice I'm not on a QCW. That's because QCW didn't exist and they couldn't send me one. So I am on a table, and there's a difference as to why you can't just take 3 journeyman rails, because people are going to ask this all the time, and make them into a Elite Series. The difference would be that the homing switch that I showed you, the journeyman rails doesn't have a port for those to have it installed to break that Y. And also the gantry block that's under here is lower than the actual feet. So the feet need something to sit on. You can see I have an aluminum plate right here. That plate raises up the Y feet tall enough for the gantry block to go. So you'll get these aluminum blocks, I believe, with your machine if you're gonna mount it to a table. If you're gonna get the QCW, you don't need those blocks because it'll sit low enough to reach. I put on 2 pieces of MDF because if I wanna go all the way down to the board, I have to get up high enough because this Z gantry is so tall. That's why they came out with the Z20 with the extra reach, because it wouldn't reach down far enough with the Z16 slider. Now you can with the heavy duty Z, it'll reach down far enough to get to the wasteboard and cut through your material. But if you are having a problem and you're not on the QCW, you're on a table like I am right now, throw on 2 pieces of 3/4 MDF and that will be your wasteboard and it'll work out just right. All right, let's talk about the accessories you may already have if you already have a Onefinity or you're looking at getting. What will work with this thing? One, your touch probe is exactly the same. It will work with this machine, and the plug is exactly the same as it is on the X35 and X50. You can use the touch probe on this. What's awesome about this machine is not only can I probe in bottom left and Z, I can probe in all directions on a square piece of material or center with this touch probe and the Masso. So I'll show that off in another video of more using the machine. This is just an introductory to it. What also can you use is your laser. If you have a JTech laser that already works with Onefinity, the plug is exactly the same and you can use it with the Masso and it'll output exactly the same. There is no difference, and that's why I have mine mounted on here because it works with the Masso. If you have a JTech laser that is connected for the Onefinity X35, X50, it will also work with the Elite. What can you not use? A joypad. Doesn't work with this Masso Elite Series machine. That's because industrial machines, which is what this Masso Elite Series is aiming to be, uses an MPG. I don't have one of those. I've never used one of those. I have one of those on order, and we'll get it in and try it out. But it's kind of has a hand dial, and you move it that way. They're much more precise, but not quite as easy as the joypad. So don't buy the joypad if you're gonna get the Elite Series, because it will not work. Shut up, Ben, turn the machine on. Okay, let me show you from the time I flip this on to the time this boots up. It is unbelievably fast. You ready? On. We have a boot screen, and we're ready to go. It was that quick. Just a few seconds and we're ready to go and move the machine. So let me show you the controls of the Masso as it is today. You might have a firmware update that changes some things. I don't know. This video could be evergreen. But let's take a look at what we have on the Masso screen. After you boot it up, you will always, every single time, have to push in the e-stop and release it. You can see the e-stop button is flashing. And release it before you can actually use the machine. This is a built-in safety feature, making sure that the e-stop works every time. So you can see up top, I'm flashing home. It wants me to home the machine. I have to double tap that and the machine will home. I also have the X, Y, and Z coordinates right here. I have the A coordinates right here, feed, the tool that's in there, laser engraving, some information, machine coordinates, the step mode or continuous mode. This is how you jog. You notice if I touch continuous mode, it's now blinking because it's telling me I am continuously going to move if I hold the finger down. Step mode will only go in steps as I touch it. We have the Z up and down, the X, Y, Z, and then we have rotary A plus and A minus. And we have our feed rate of how quick I want to jog. It's a slider. It moves like that. This button over here is for my touch probe. And then we have an on-screen keyboard right here. And then finally, this is our G-code visualization viewer, so I know what the visualization of my G-code will look like. So let's first home the machine. I'm gonna zoom out so you can see what it does. All right, I'm gonna double tap home. Z is homed. It's gonna come over here and it's gonna optically sense home with the optical sensor up here. And the speed of homing is adjustable in here if you want to change it for the advanced user. Now we're going to home in Y, and you're going to notice one is going to hit before the other and it'll straighten itself out. Do you see how it tilted and straightened itself out because that one was off? So independently homes Y1 and Y2, which is pretty awesome. Homing has now stopped flashing, so we're ready to use the machine. I'm going to go ahead and click on step mode, and I'm going to increase the step from 0.0005, because if I'm tapping it here on the screen, you don't even see it move, to 0.1, and now you can see it move. And every time I tap on the screen, it's going to move the step. If I hold it down, it does nothing because I am on step mode. If I click on continuous mode, I can drag how fast I want it to move. So let's say 12%. If I hold the X plus button, I'm moving at 12%. That's pretty slow. If I drag it all the way over to the right at feed 100, now you can see if I hold the button down, it will go in continuous mode. If I go back to the back, it will go back. If I do Z, it'll go up and down like that. So that is step and how you jog. All right, I'm cutting in close, so hopefully you can see the screen. I'm gonna bring that closer to the front. You can see how easy it is. Let's just pretend I'm zeroing my material right there. The way you zero up here is a button. We have X, Y, and Z. I'm gonna tap X. That zeroes the machine in X. I'm gonna tap Y. You notice all the coordinates changes to 0. Now I'm zeroed in Y, and I'm gonna tap Z, and that's my coordinates at Z. I do have absolute coordinates over here, where the machine is in relative to the home's position. So that's how you home. So that's how you zero X, Y, and Z. You tap these buttons independently and it will zero. Now I'm going to try to give you a brief overview of the other things that are up top. So you can see we are on Masso G3 5-axis 5.02. That's my firmware. The probe is connected. I'm working with the work offset of G54. Yes, G54 to 59 offsets are enabled in this. MPG access, that's the joypad for lack of a better term. That's off because I don't have one. Optional stop is on. I have run 8 jobs on this in the last count, and my Wi-Fi is connected and it has a time of 1:04 p.m. So outside of that, I have F1 goes to setup. I have a ton of things in the configuration to change. Most likely you will never ever use any of this in here, and if you change any of this, you will screw up your machine. Don't go to F1 if you don't know what you're doing. F2, this is the program view. You can see the top bar looks exactly the same. This looks the same. This looks the same. This over here looks completely different. We have move up and down, laser, air assist, single block, coolant flood, go to work origin, jump to line, MDI, rewind, escape, feed hold, and cycle start. We also have G code and overrides. This is where if you're running a carve and you want to go overriding the speed, you'll drag the slider to change the speed on the fly. We also have spindle speed / laser power speed to change on the fly. I can change this laser power from 100 to 150 or down to 10%. Generally on a laser, you're going to probably have it at 100% normally, and that's what it'll look like. If I had G-code loaded, it would show me my G-code here, and these buttons turn things on. I'll show that in a second. Jog and probing is where we started, so we looked at everything on here except for the probing button, so let's tap it. Here's where we probe. So you notice we have different corners where we can probe. It has a square block, and we can tap either one of these, and it will probe in any of those corners. I have some settings for the offset of my probe, the thickness probe, and up here, probe diameter, that's the one you're going to use most often. That is how big of a tool you're using, the cutting part, not the shank. So last time I used a 0.25 inch cutter, a 1/4 inch, and that's what was in here. So I can tap this and probe here. I can tap this and probe here. I'm going to hit the E stop because I shouldn't be probing anything. You can see how it stopped because I didn't have my probes set. And that is how you'll set your probe. I'll do another video of this in the future. Tool offsets, you can list your tools in here. So if we have general tools we use, an 1/8 inch, a 1/4 inch, the laser, etc., and I like offsets, that will be up here. And then your G54 to G59 plus your parking. So if you wanted to stop somewhere and park in the back, you can do that down here. This is again for advanced users, but the G54 to G59 work offsets are here, and you can set tool numbers in here. Finally, conversational. This is something I haven't used, and I really don't know much what it does. We'll look at that in a later video. F6 is load a file. You'll notice all these things around here are normal, except for over here, this is new. We have our files that are on the USB. So you can see it just input what I'm going to cut. This is a laser file, so you can see what the G code is going to look like. I'm going to start in the bottom left. It's going to do these white dashes and move when it's not actually lasering. You can see how far it's going to go, so 4.0593 inches this way and 1.846 inches up. So we can see where our G code is. It also gives us a 2D view and a depth map. So if you have 3D carves, you're going to be able to click on that and see the depth map of that. And what's really sweet, when you click load, you can click on edit, and that brings up the G code line by line, and I can page down and page up. And if I realize that this tool is going to go too slow, if I'm like, oh no, the power isn't strong enough, I can click on a line and I can literally edit that line and type in whatever I want and hit save, and that G code is saved forever. A great example for this would be I do a file over and over, cutting the same circle over and over, something like that, and I realize 100 inches a minute is too slow and I want to do 200. I don't have to go back to a computer. I can edit it here, save it, and that G code will always be whatever I edited to. theoretically, you can write your own G-code within the controller. We also have plus new. I can name a file. I can hit save. And look, it came up with new G-code. Now I can say G0 and blah, 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 and save the file. And I wrote a new file. You can see there's a new G-code there. I can also delete that G-code if I don't like that G-code. So that is the G-code loader here. All right, I made a file on here. So I plug that in. I made it on the computer. I'm gonna go to load file. It's called circle. We're gonna load it. You can see it's just a big circle. It's taking up a whole lot of this bed. That's how easy it is to load the file, and I can see what it's like. So let's go ahead and bring this to the front. I'm not gonna carve it. I'm just gonna air carve it so you can see it, move, and I can talk to you still. I'm gonna go ahead and jog to the front. I'm gonna guesstimate in zeroing. Just gonna pretend like that's our 0, and our file is loaded. So I'll go to Program and MDI, and I'm gonna go ahead and start the file. And we did X, Y, Z, and it will now start the program. So this is what it'll look like when you start a program. Load tool, I've already done that. Hit start, and it would turn on the spindle. You can hear some of the clicking. And now we're gonna run at 400 inches a minute. You can see my feed rate is 400 inches a minute, cutting out this circle. So that's how smooth it is, how quiet it is. It's much quieter machine with the stepper drivers that the Masso is using in the Elite series. So that's how easy it is to use the Elite in cutting material and setting it up. Again, the setup was the exact same as it was with the X50. They are all pre-made rails. It is like 16 bolts to put this thing together, and it will take you less than 30 minutes. It takes me maybe 10 now. I've done it so many times. So that is the first look at the Elite machine. Hope you like it. Check out Onefinity for more videos. If this video helped you at all, make sure to hit the like and subscribe button. I'm gonna come out with more Elite videos as I have time to dive in to really how to use this machine and what more of the functions do. And I'll be back in the future with more. Thanks for watching. Happy cutting.